Hi, this is Mr. Yeager, Physical Science again. This is kind of the last section, very quick, of basically skills needed for physical science that we're going to use throughout physics and chemistry of the sections in physical science. So this one's on measuring, and basically I'm going to go through how you measure length, temperature, volume, I think something else too, but basically kind of talking about a little bit of units and how we measure them. All right. So again, the primary units we use in physical science are going to be distance, mass, volume, and temperature. All right, those are the ones that are going to be involved in our formulas that we're going to be using throughout the year. Distance is measured in meters. A lot of times, though, we might see it in centimeters. Mass is measured in grams or kilograms. Okay, again, kilo just being 1,000 times larger than grams. Volume, milliliters and liters. Temperature, degrees Celsius. Now, another one I should have on here too, but I just don't include it because I feel like everybody knows how to do this, is measuring time in seconds. Obviously, we measure time with a stopwatch. Okay, a stopwatch. All right. So there's nothing too special with that in seconds. Okay. So we need to know the device that we use. We have rulers or meter sticks for distance. We have a balance that measures mass. Again, there's a triple beam balance. I feel like nowadays everybody's moved on to the electronic balance, so it's going to be even easier, but I'm still going to show you how to read a triple beam balance. Graduated cylinder for measuring volume, and thermometer for measuring temperature. Okay? So again, I feel like most of this stuff is pretty common. Maybe the only thing that's really not common at all is a graduated cylinder for most people. But we know balances measure mass. It's the same thing as a scale, okay, and so forth. All right? So again, make sure which unit the equipment is trying to tell you to use. We call it a piece of an instrument or a piece of equipment. Figure out if the increments are, what do these increments represent? Are the lines representing 1 centimeter, 0.1 centimeter, or 2 centimeters? I mean, I say that because sometimes we have some interesting rulers and stuff that come out on these questions where it's like, there's 1, 2, 3, 4, and then this is 10. And you're like, wait, what? So this is 2, 4, 6, 8. So just be aware of that. Every line doesn't necessarily mean 1, okay? Estimated digits, I'm not so worried about that. I'm going to kind of actually ignore that for the time being. The idea of the estimated digit is you're supposed to then estimate the distance between the two lines that you can actually see. That's not as important for physical science. I mean, I'll still try to use it a little bit. So let's measure some of these lengths. Basically, what do I got here? I can clearly see this is in millimeters. Okay, so measure of distance. I'm going to measure basically the length of the screw, not the screw head, but the length of the screw. So this is all 1, 2, 3, 4, 5, 6, and then there's 10 things in between. So this must be 6.1, 6.2, 6.3, 6.4, 6.5. I'm going to say 6.5 millimeters. Get the units there. All right, what about the second one? We can see we got we got in centimeters this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these all must be point centimeters, so 0.1, 0.2, 0.3. I have 1, I'm 1 short of 2, so this would be 1.9 centimeter. If I want to do the estimated digit, which I'm not going to probably ask for, that would be like the fact that it's not exactly on 1.9, so maybe I say 1.93. The thing is, somebody else could come along and say 1.92, 1.91, etc., etc. The last one is in inches and in centimeters. I'll basically let you go and try that if you want to yourself. I think it comes out to 3.5 inches and 8.9 centimeters. Okay, so that's length. What about finding mass? This is the old triple beam balance. Okay, with the triple beam balance, we're going to assume this is in grams. It doesn't say it, but usually these things are in grams. It should have it written. We have to basically start with the largest beam. This is a triple beam because each beam is representing a different order of magnitude in terms of that mass. So the middle beam is basically telling you 100, 200, 300, 400, 500, 600, up to 1,000. The top beam is counting by tens. The bottom beam is basically counting by 0.1 grams because, again, 0.1, 0.2, 0.3, etc. Okay? So how would I read this? Well, there's 0 from the largest, 20 from the tens unit, and then this one is on 7.7. So I basically just add those two up. So the total here is 27.7 grams is what this object is up here. How about my next one? I got 335 grams. The last one down at the bottom, a little tough to see. I have 370. The thing is, that's at 4, so this must be 3. 373.3. 373.3 grams. Okay. would be that one at the bottom. Again, starting with the largest and going to the smallest. For volume, you want to measure what's called the meniscus, the bottom of the curve. I know it's a little bit blurry here. The bottom of the curve, that's called the meniscus. So we measure from the bottom. So this would be right here for this one, 15, basically 16 milliliters. Again, I know it's tough to see, but here's 15, 16, 17, 18, 19, 20. Okay? Over here, this is a tricky one. You have to see how this is 10 and that's 20, so this must be 12, 14, 16, 18. So this is around 14 milliliters, etc. So you always read from the bottom of the meniscus. This one over here would also be 14 milliliters. Okay? This one back here, this goes by twos. I think it's at basically 12 milliliters. All right? So again, read the bottom of the curve, the meniscus, the very bottom. Finding temperature, again, just read the thermometer. Okay? It's a little bit, sorry, it's being a little blurry here. I'm only going to do Celsius because that's really the only one we use. But I can see that this is basically at 5 degrees Celsius. Oops. Oh, dang it. Oh, sorry guys. 5 degrees Celsius. Right here, 5 degrees. Right here, this one's at 0 degrees Celsius. And over here, this one's at 10 degrees Celsius. Celsius is our standard unit for temperature in science. All right. The last thing I could show you, if it happens to show up, is what we call volume displacement measurements. Volume displacement. And this is where you place an object in water that has a weird shape that you can't really measure easily with a ruler. And you see how much the water has gone up. Sorry. How much the water, let's switch that. It's being weird. How much the water has gone up. Okay, from before you added the device. So for instance here, this object right here, with only the water in it, this is at 19 milliliters. But then I add this strange object, and all of a sudden I'm at 29 milliliters. So then what's the volume of this object? This is taking up how much space? 29 minus 19 equals 10 milliliters. All right? So basically you take two volume measurements and then just subtract them. Over here, I'm at 64. Over here, I'm at 68. So what's the volume of this ring? 68 minus 64, 4 milliliters. So that's called volume displacement. Not sure if you're going to really run into that so much anymore, like I wrote, it's a bonus, but still worth knowing. Good technique to figure out the volume of a strangely shaped object. And that's basically it. Thank you.